Before we begin, find a comfortable place to rest. Let your shoulders soften and let your breathing become slow and easy. Tonight, we are going to drift far beyond the familiar planets of our own solar system, out into the quiet dark where other worlds are waiting in silence. Some of these worlds circle distant stars. Some hide in the glare of their suns. Some pass in front of their stars only for a few hours, making the starlight dim by the smallest amount. And some may not orbit any star at all. They move alone through the galaxy, cold and unseen, like tiny islands in an endless night. This is not a journey that needs to be rushed. There is no need to remember every number, every name, or every detail. You can simply listen, without trying to hold on to everything. Let each idea arrive softly, like a small star appearing in a dark sky, and if your mind begins to wander, that is perfectly fine. You can follow the sound of the words for as long as you like. Most planets in the galaxy are hidden from direct view. When we look up at the night sky, the stars seem to be the main characters. They shine, flicker, and mark the constellations we have known for thousands of years. Planets are much quieter. They do not make their own light in the way stars do. Most of the time, they only reflect the light of the star they orbit, and when they are very far away, that reflected light becomes almost impossible to separate from the star's brightness. For most of human history, we could only see the planets in our own solar system. The rest were hidden, not because they were rare, but because they were faint. A distant planet beside its star is a little like a firefly hovering beside a lighthouse. The firefly may be there, glowing gently, but the lighthouse overwhelms it. This is one of the strangest things about the universe. There may be planets almost everywhere, yet most of them remain invisible to the eye. They are not hidden behind walls. They are hidden by distance, brightness, and silence. Many hidden planets are discovered by watching stars dim slightly. One of the most successful ways to find a planet is not to see the planet itself. It is to notice what the planet does to its star. If a planet passes directly between its star and us, the star's light dips by a tiny amount. This is called a transit. The planet is not blocking the whole star. It is only crossing a small part of the star's face, like a dark bead moving across a glowing lamp. The change can be incredibly small. Sometimes the star dims by less than 1%, but sensitive space telescopes can notice that quiet rhythm. The star becomes bright, then slightly dimmer, and bright again. Days, weeks, or months later, the same tiny dip may happen again. That repeating pattern tells astronomers that something is moving around the star. A hidden planet has left a shadow. There is something peaceful about this method. The planet does not announce itself, and it does not shine brightly. It simply passes across the light again and again, keeping time in the dark. Some hidden planets orbit so close to their stars that a year lasts only a few days. When we think of a year, we often imagine the slow turning of seasons. Spring becomes summer, summer becomes autumn, and autumn fades into winter. Earth takes about 365 days to travel once around the sun. But around other stars, some planets move much faster. These worlds may complete a full year in only a few Earth days. Some race around their stars so quickly that their calendars would feel almost impossible to imagine. A world like that would live close to intense light and heat. Its star would fill a large part of the sky. Many close-in planets were among the first kinds of exoplanets we could easily detect. They pass in front of their stars often, so each orbit gives another chance to notice a small dip in light. Some of these worlds are giant planets, larger than Jupiter, but much closer to their stars than Mercury is to our Sun. Astronomers often call them hot Jupiters. They are strange because they are both massive and close. They are wrapped in heat, moving through short and repeating years. A hidden planet does not have to be far away to be mysterious. Sometimes it hides in the brightest place of all, very near its star. Not every hidden planet passes in front of its star from our point of view. The universe is full of angles. A planet may orbit a star perfectly normally, but its path may not line up with Earth. If the orbit is tilted from our perspective, the planet may never cross the face of the star. No tiny shadow appears, and no regular dimming reaches our telescopes. The planet is still there. It is simply not passing through our line of sight. This means every planet hunting method has a blind spot. The transit method is powerful, but it favors planets whose orbits happen to be edge-on from Earth. It is a little like trying to find moths around a lamp by waiting for them to pass between your eye and the flame. Some will cross your view, but many will not. That is why astronomers use different techniques together. They watch for shadows, study star wobbles, measure starlight, and use gravity itself as a clue. Each method reveals a different part of the hidden planetary population. Each one opens a slightly different door in the dark. There may be many planets around nearby stars that we have not found yet. Some are hidden simply because they are turned the wrong way in the sky. You can let that thought drift past you slowly. A world can be real, even when it never crosses our view. Some hidden planets reveal themselves by making their stars wobble. A planet orbits a star, but in a quiet way, the star also moves because of the planet. The star does not sit perfectly still at the center. Instead, both the star and the planet move around a shared center of mass. If the planet is small, the star's motion is tiny. If the planet is massive, the star's motion becomes easier to notice. From far away, this can make the star appear to wobble. Astronomers can detect this wobble by studying the star's light. As the star moves slightly toward us, its light shifts a little. As it moves away, the light shifts the other way. These changes are extremely subtle, but they can reveal an unseen planet tugging gently on its star. This method does not show us a picture of the planet. It shows us the star responding to something hidden. There is something beautiful about that. The planet is invisible, but its gravity leaves a signature. A silent world reaches across space and causes a distant star to sway. It is like someone in the dark pulling softly on a lantern string. Some hidden planets may travel in wide, cold orbits far from their stars. Not every planet stays close to warmth. Some worlds may orbit far away from their stars, in regions where sunlight is weak and slow. Their years could last decades, centuries, or even thousands of Earth years. A single orbit might be longer than the history of a civilization. These planets are difficult to find with the transit method because they may pass in front of their stars very rarely. We may simply not be watching at the right time. A planet with a 500-year orbit might cross its star once, and then not return for many human lifetimes. Wide-orbit planets can also be hard to detect through stellar wobble. Their gravitational rhythm is long, patient, and slow. Astronomers may need many years of observations to notice the pattern. Some hidden worlds do not move on a schedule that is convenient for us. far from the glare of their star, these planets may receive only pale and distant light. They may have long winters, faint noons, and quiet frozen skies. In the deep outer regions of a planetary system, a planet can remain hidden not because it is small. It can remain hidden because it is patient. Some hidden planets may wander through the galaxy without any star. These are often called rogue planets or free-floating planets. They may have formed around stars long ago and then been thrown out by gravity. Another planet may have passed too close. A young solar system may have become unstable, sending one world away into the dark. Some rogue planets may have formed more like tiny failed stars, born from collapsing clouds of gas. But they never became massive enough to shine. Either way, the idea is quiet and strange. A planet without a sunrise. A world with no morning. Rogue planets are extremely difficult to find because they do not orbit a bright star. There is no regular transit and no familiar starlight to dim. Many of them may be cold and dark, giving off only a tiny amount of heat. They may move through interstellar space almost completely unseen, but gravity can still reveal them. If a rogue planet passes almost exactly in front of a distant background star, its gravity can bend and magnify the star's light for a short time. For a brief moment, the hidden planet acts like a natural lens. It does not shine, but it bends light. Some of these events can be very short, especially if the object is small. A hidden world may reveal itself only for minutes or hours, and then vanish again into the galaxy. It is a soft reminder that the universe may be filled with things we only glimpse once. A passing shadow, a bent ray of starlight, a planet with no star. As we settle deeper into the night, we can imagine those hidden worlds continuing their slow journeys. Some are close to their suns, some are far from warmth. Some move completely alone. They do not need to be seen to exist. They do not need to be bright to be real. They are simply out there, quiet and patient, waiting for the right kind of light to reveal them. Some hidden planets are discovered because their gravity briefly magnifies the light of a star behind them. This method feels almost dreamlike. A planet may be too dark to see, too far from its star, or drifting alone through space. But gravity still gives it a quiet way to be noticed. When a hidden planet passes in front of a much more distant star, its gravity can bend the background starlight. For a short time, the distant star may appear brighter, as if space itself has become a lens. The planet does not need to glow. It does not need to pass in front of its own star, and it does not need to orbit close to anything bright. It only needs to cross the right path at the right moment. These events are rare from our point of view because the alignment has to be very precise. A hidden planet, a distant background star, and Earth all have to line up in just the right way. But when it happens, astronomers can sometimes detect a world that would otherwise remain completely unseen. There is something gentle about that idea. Even a dark planet, far from warmth, can bend a little light and leave a trace. Some hidden planets may have oceans beneath frozen surfaces. In our own solar system, several icy moons are thought to hide liquid water below their crusts. This makes scientists wonder whether distant hidden planets might also keep oceans buried under ice. A planet far from its star might look frozen and lifeless from the outside. Its surface could be hard, pale, and silent, reflecting only weak sunlight. But deep below that frozen shell, heat from the planet's interior could help keep water liquid. Radioactive decay, tidal forces, or leftover heat from formation might warm the hidden layers. Such a world would not need blue skies or warm beaches to have an ocean. Its sea could be sealed away in darkness, protected from space by miles of ice. This is one reason hidden planets feel so mysterious. The outside of a world does not always tell the whole story. A frozen planet may not be entirely frozen. A silent surface may be covering movement below, and somewhere beneath the ice, in a place with no sunrise, liquid water might slowly shift in the dark. Some hidden planets may be larger than Earth, but smaller than Neptune. Astronomers sometimes call these worlds super-Earths or mini-Neptunes, depending on what they are made of. They are among the most common types of planets found around other stars, yet our own solar system does not have one. That is a strange thought. One of the most common kinds of planet in the galaxy may be missing from the planetary family we know best. A super-Earth is not necessarily like Earth. The name mostly means it is larger than our planet, but still smaller than an ice giant like Neptune. Some may be rocky, with thick atmospheres and heavy gravity. Others may be wrapped in deep layers of gas, water, or exotic high-pressure materials. A mini-Neptune could have a dense atmosphere so thick that no solid surface is easy to define. It might be more like a small ice giant than a familiar rocky world. These planets are hidden from direct experience because we have no nearby example to walk around in our imagination. We know they are out there, but we are still learning what they truly are. Some hidden planets are so close to their stars that one side may always face the light. This can happen when a planet becomes tidally locked. The same side of the planet always faces the star, while the other side remains turned toward space. On one half of the world, there could be endless day. On the other half, endless night. The star-facing side might be bright, hot, and still. The far side might be cold, dark, and quiet, never seeing a sunrise. Between them, there may be a narrow region where the star hangs low near the horizon. This twilight zone could be one of the more comfortable places on such a planet, depending on the atmosphere. If the planet has thick air, winds might carry heat from the day side to the night side. The atmosphere itself could become a slow-moving blanket, softening the difference between light and dark. A tidally locked planet sounds strange at first, but in the galaxy, it may be very common, especially around small red dwarf stars. The idea is peaceful in a curious way. One sky forever lit, one sky forever dark, and a twilight band between them where the star never fully rises or sets. Some hidden planets may orbit red dwarf stars, the smallest and longest-lived stars in the galaxy. Red dwarfs are dimmer and cooler than the sun. Because they are faint, their planets can be difficult to study, especially if the systems are far away. But red dwarfs are very common. Many of the galaxy's planets may orbit these small, quiet stars. A planet around a red dwarf must often orbit close to receive enough warmth. This makes the planet easier to detect when it passes in front of the star, because the orbit is short and the transit repeats more often. But living near a red dwarf can also be complicated. Some red dwarfs produce strong flares, sending bursts of energy into space. A hidden planet in that kind of system might need a strong atmosphere or magnetic field to protect its surface. Or it might keep its most interesting chemistry beneath oceans, ice, or rock. Still, red dwarf systems are deeply important in the search for hidden worlds. They may hold countless planets, moving quietly around stars, too faint to see with the naked eye. A red dwarf may look modest compared with the sun, but around it, entire worlds may be turning in the dark. Some hidden planets may have skies filled with unfamiliar colors. A planet's sky depends on its atmosphere, its star, and the particles floating in its air. Earth's blue sky is not the only possibility. Around a redder star, sunlight would arrive with a different balance of colors. In a thick atmosphere, clouds, haze, and dust could scatter light in ways that feel completely unfamiliar. Some worlds may have golden skies. Others may be orange, violet, gray, or dim red. A planet with methane haze might have a soft, smoggy glow. A world with reflective clouds could shine brightly from space, while its surface remains hidden below. Some planets may never show a clear sky at all. They may be wrapped in permanent cloud layers, hiding their surfaces from any telescope looking from far away. This is another kind of hiddenness. A planet can be found, named, and measured while its surface remains unseen. We may know its size, we may know its orbit, we may even know something about its atmosphere, but below the clouds, there may still be landscapes no one has imagined correctly. Some hidden planets may be covered by global oceans. A water world is a planet where oceans may cover most or all of the surface. There may be no continents, no dry valleys, and no mountains rising into open air. From space, such a planet might look calm and blue, but it could be very different from Earth. If the ocean is extremely deep, the pressure at the bottom may become so intense that water forms exotic kinds of ice. These high-pressure ices can exist even when the temperature is not cold in the ordinary sense. This means a deep water world might have an ocean separated from its rocky interior by layers of strange ice. That could change the chemistry of the planet in important ways. Other water worlds might have shallower seas, allowing water and rock to interact more directly. Those interactions could shape minerals, gases, and perhaps even the possibility of life. The peaceful image of a global ocean hides many questions. How deep is the water? What lies beneath it? Is there weather? Are there storms? Is the ocean still or always moving under alien moons and distant sunlight? A hidden planet can be simple in outline, yet incredibly complex inside. Some hidden planets may have rings that are difficult to detect. When we think of rings, Saturn comes to mind first, bright and graceful in our own solar system. But rings may exist around planets in other star systems too. From far away, a ring system could make a planet's transit look unusual. Instead of a simple dip in starlight, there might be a more complicated pattern as the rings begin to cross the star before the planet does. But detecting rings around exoplanets is very difficult. The signal is small, and many other effects can confuse the measurement. A ringed, hidden planet would be especially beautiful to imagine. A dark world surrounded by thin bands of ice, dust, and rock, quietly circling a distant star. The rings might be young and bright, or old and faint. They might spread wide into space, casting soft shadows on the planet below. There could even be moons moving within the ring system, shaping gaps and waves, like tiny shepherds guiding a river of dust. Most of these details would be far beyond what we can currently see. But the possibility is enough to make the hidden planet feel more real. Out there, in some quiet orbit, A world may be wearing rings no telescope has clearly revealed yet. And as these thoughts drift by, there's no need to hold on to every detail. You can let the planets move slowly through your mind, one after another. A frozen world with a buried ocean, a red sky planet near a dim star, a dark ocean world without land, a ringed planet hidden in the glare. Each one is only a quiet possibility, resting somewhere in the wide night. Some hidden planets may travel on stretched, oval-shaped orbits. Not every planet moves around its star in a nearly circular path. Some follow long, eccentric orbits that carry them close to the star, then far away again. On a world like this, the seasons could be extreme. For part of the year, the star might grow large and bright in the sky. Later, the same star could shrink into the distance, leaving the planet colder, dimmer, and quieter. A planet in a stretched orbit may be hard to understand from a few observations. Its speed changes as it moves, and its temperature may shift dramatically across its year. When it is close to the star, its atmosphere may warm and expand. When it moves away, clouds may form, gases may condense, and the whole world may settle into cold. There is something almost breathing about such an orbit, near and far, warm and cold, bright and dim. A hidden planet like this does not live in one steady climate. It travels through changing light again and again. Some hidden planets may orbit 2 stars at once. These are called circumbinary planets because they circle around a pair of stars instead of just one. Their skies would be very different from ours. Imagine standing on a planet where 2 suns rise and set together. Sometimes they might appear close in the sky, and sometimes they might drift apart. The shadows on the ground could overlap and separate. Sunrise could feel doubled, with one star following the other through the morning. Finding these planets is difficult because the light from 2 stars can change in complex ways. The stars may eclipse each other, and the planet may add its own smaller signal. Astronomers have to untangle all those patterns carefully. They look for repeated dimming that cannot be explained by the 2 stars alone. A hidden planet around 2 stars feels like something from a dream, yet such worlds are real. They move through the gravity of a double sunrise. Their years are not just measured by 1 star. They are shaped by a slow dance of 2. Some hidden planets may orbit 1 star in a binary system. Many stars in the galaxy are not alone. They belong to pairs or groups, held together by gravity across large distances. A planet in such a system may orbit 1 star, while another star shines far away in the same sky. That second star might look like a bright point, a tiny sun, or a distant ember. Depending on the distance between the stars, the planet's orbit may be stable for a very long time, or the companion star may gently disturb the system over millions of years. This makes binary star planets interesting and complicated. Their hidden lives are shaped not only by 1 sun, but by another star watching from afar. The night sky on such a planet might be beautiful. 1 star could set, while the other remains visible in the darkness. There may be nights that are never fully dark. There may be seasons when the second star glows brighter than usual. A hidden planet does not need a simple sky. Some worlds may grow up beneath the quiet influence of more than 1 sun. Some hidden planets may be darker than charcoal. A planet's brightness depends on how much light it reflects. This is called its albedo. Earth reflects some sunlight back into space because of clouds, ice, oceans, and land. Other planets may reflect much less. Some hot giant planets are thought to absorb most of the light that reaches them. Their atmospheres may contain chemicals that soak up starlight instead of scattering it back. From far away, these planets can be extremely difficult to see directly. They may be large, but they are dark. A world like this could orbit close to its star and still look almost black against the surrounding space. It would not shine like a pale pearl or a blue marble. It might be more like a shadow moving through firelight. That image is strange but quiet. A giant planet wrapped in darkness, warmed by a nearby star, yet reflecting almost nothing. Some planets hide not because they are small. They hide because they drink in the light. Some hidden planets may be slowly losing their atmospheres. When a planet orbits very close to its star, intense radiation can heat the upper atmosphere. Over time, some of that gas may escape into space. This can create a faint, extended cloud around the planet. In some cases, a planet may leave a tail of escaping material, almost like a comet. The planet is still there, but it is changing. Its atmosphere is being shaped by light, heat, and time. For small planets close to active stars, this process can be especially important. A world that once had a thick atmosphere might slowly become more bare. A mini Neptune might lose gas and become more like a rocky super-Earth. A planet's identity can change across billions of years. This is one reason hidden planets feel alive in a geological sense. They are not frozen labels in a catalog. They are worlds with histories. They form, migrate, heat, cool, lose gas, gain scars, and settle into new states. Even in the dark, a planet is not always still. Some hidden planets may have tails of dust. There are small, very hot worlds that orbit so close to their stars that their surfaces may begin to break apart. Rock can vaporize, and dust can stream away into space. From far away, such a planet might not create a clean, simple transit. Instead, the dimming of the star may look uneven because the dust cloud changes shape. The planet may be slowly disintegrating. It may leave behind a soft trail of minerals, like ash drifting from a candle flame. This sounds dramatic, but it can be described gently. It is a world being worn down by its star, grain by grain, orbit by orbit. Each time it circles, a little more material may escape. The planet becomes a hidden source of dust, moving in a rhythm too distant to see with ordinary eyes. Astronomers can study these strange light patterns to learn what might be happening. The planet itself may be too small to see, but its fading trail gives it away. A hidden planet can leave footprints made of dust. Some hidden planets may be lava worlds. If a rocky planet orbits extremely close to its star, the surface can become hot enough for rock to melt. Instead of oceans of water, there may be oceans of lava. One side of the planet may glow with molten material. The surface could be covered in dark basalt, bright cracks, and slow rivers of melted stone. If the planet is tidally locked, the day side may be a furnace while the night side remains much cooler. Winds may carry vaporized rock around the planet. On the colder side, minerals might condense and fall like strange rocky snow. The weather would not be made of water, but of stone. These worlds are hidden from us in detail. We may know their size, mass, and orbit, but not the shape of their glowing landscapes. A lava planet is not peaceful in the ordinary sense. But from far away, it becomes part of the quiet order of the universe. A small hot world circling close to its star, shining faintly with its own molten surface. Some hidden planets may be covered in thick clouds forever. Clouds can hide a planet more completely than distance alone. A telescope may detect the planet's atmosphere, but still fail to see what lies below. Thick clouds can flatten the signal astronomers hope to read. They can cover the chemical fingerprints of deeper layers. This makes cloudy exoplanets both frustrating and fascinating. They are discovered, measured, and confirmed, yet still secretive. A cloud-covered world might have oceans below. It might have mountains, deserts, storms, or a surface crushed beneath heavy air. But from far away, the clouds become a veil. Venus in our own solar system is a familiar reminder. Its bright clouds hide a harsh surface that was unknown for a long time. Around another star, a cloudy hidden planet could keep its secrets even longer. It may show us only the top of its atmosphere. Everything below remains part of the dream. Some hidden planets may have atmospheres that sparkle with exotic rain. On Earth, rain is water. But on other worlds, rain could be made of very different materials. In the atmospheres of some hot giant planets, temperatures and pressures may allow unusual clouds to form. Minerals, metals, or other compounds may condense high in the sky. On cooler giant worlds, methane or other chemicals may play a role in weather. The idea of rain becomes much broader when we leave Earth behind. A hidden planet could have clouds made from substances that would feel completely unfamiliar to us. Its storms might glitter, darken, or glow in ways no human weather has done. This does not mean every strange rain story is certain. Many details are still models, measurements, and careful guesses. But the possibility is enough to widen the imagination. Weather is not one thing across the universe. A planet's sky is a chemistry set, shaped by heat, pressure, gravity, and light. Somewhere, hidden behind the glare of a star, rain may be falling in a form we would not recognize. Some hidden planets may be almost impossible to classify. When astronomers first find a planet, they may know only a few things. They may know its size, its orbit, or a rough estimate of its mass. But those clues do not always tell the whole story. Two planets with similar sizes can be made of very different materials. One could be rocky and dense. Another could have a thick atmosphere and a lighter interior. A third could be rich in water, with deep oceans or high-pressure ice. From far away, their shadows may look similar. This is why hidden planets often live between categories. They are not always clearly Earth-like, Neptune-like, or Jupiter-like. They remind us that nature does not need to follow the simple boxes we create. The galaxy may contain many kinds of worlds we have not named well yet. A hidden planet can be partly familiar and partly strange. It can sit between rock, water, gas, and ice. And as the mind begins to rest, that thought can drift quietly by. There are worlds out there that do not fit our old maps. They wait in the spaces between the names we already know. Some hidden planets may have moons that are easier to imagine than to detect. In our own solar system, moons are everywhere. Jupiter and Saturn have large families of them, and some are almost like worlds of their own, around distant stars. Exomoons may also exist. But finding them is extremely difficult. A moon is usually smaller than its planet. Its signal is weaker, softer, and easier to confuse with noise. If a planet passes in front of its star, a large moon might create an extra tiny dip in the starlight. It might also slightly change the timing of the planet's transit, but these effects are subtle. They require careful observation, repeated patterns, and a great deal of patience. A hidden planet with moons would be a beautiful system. There could be tides, eclipses, shadows, and slow dances of gravity. A moon might cross the face of its planet. The planet might cast a wide shadow over the moon. From the surface of that moon, the hidden planet could fill the sky like a giant lantern. Somewhere far away, there may be moons circling worlds we have barely detected. Some hidden planets may be warmed by tidal forces instead of sunlight. Tidal heating happens when gravity stretches and squeezes a world as it moves. This can happen when a planet or moon follows an orbit that is not perfectly circular. The world bends slightly under the pull of gravity. That bending creates heat inside. In our own solar system, this kind of heating helps make some moons surprisingly active. A small world can stay warm inside, even far from the sun. Around other stars, hidden planets may also experience tidal heating. A planet close to a small star, or pulled by nearby worlds, could have an interior kept warm by gravity. This matters because warmth does not always have to come from sunlight. Sometimes, it comes from motion, pressure, and the slow kneading of a planet's interior. A hidden planet might look cold from far away, but deep inside, it could be restless. Its rocks may shift. Its oceans may stay liquid. Its surface may hide a warmer story below. Some hidden planets may have powerful magnetic fields. A magnetic field can act like an invisible shield. It can help protect a planet's atmosphere from charged particles flowing from its star. Earth has a magnetic field, and it helps shape the space around our planet. It also gives us auroras, those soft curtains of light near the poles. On another planet, a magnetic field could be stronger, weaker, or arranged in a very different way. A giant planet may have a powerful magnetic environment. Charged particles could move along invisible lines, creating glowing regions in the atmosphere. For hidden planets, magnetic fields are hard to measure directly, but they may be very important for understanding how a planet changes over time. A small world near an active star might struggle to keep its air. A magnetic shield could make a difference. It is quiet to imagine a planet wrapped in something unseen. Not a wall, not a shell, but a field. An invisible shape around a hidden world, holding back the wind from a distant star. Some hidden planets may have auroras brighter than anything on Earth. Auroras happen when charged particles interact with a planet's magnetic field and atmosphere. On Earth, they can glow green, red, purple, or blue. On another world, the colors could be different. The brightness could be stronger, especially if the planet is near an active star. A giant planet with a powerful magnetic field might have auroras that circle its poles like glowing crowns. They could pulse slowly as particles stream through space. If the planet has moons, the interaction could become even more complex. A moon moving through the magnetic field might help create extra glowing regions. We cannot stand there and watch them. But the idea is gentle and strange. A hidden planet, dark to our telescopes, may still have light moving through its upper atmosphere. Not sunlight reflected from clouds, not city lights from a surface, just the quiet glow of charged particles, tracing invisible magnetic paths through the night. Some hidden planets may have atmospheres so deep that pressure changes everything. On Earth, The atmosphere feels open and light to us, even though it has weight. But on some planets, the atmosphere may be much thicker. A dense atmosphere can press down with enormous force. It can change how gases behave, how clouds form, and how heat moves around the planet. On a rocky world with heavy air, the surface might be hidden beneath haze and pressure. The sky might feel less like empty space and more like an ocean of gas. On a mini Neptune, the atmosphere may be so deep that there's no clear surface like the ground beneath our feet. The deeper layers may gradually become hotter, denser, and stranger. A hidden planet like this challenges simple imagination. It may not have land, sea, and sky in the familiar sense. It may be layers upon layers, clouds above haze, haze above heavy gas, gas above compressed material. A world like that would not be easy to picture. But it would still be a planet quietly following its orbit. Some hidden planets may be rich in carbon. Different planets can form from different mixtures of material. If a planet forms in a region rich in carbon, its rocks and chemistry may be unusual. Some scientists have imagined carbon-rich planets where minerals are very different from those on Earth. In extreme cases, high pressure could even create layers containing diamond-like material. This does not mean there are glittering jewel planets waiting everywhere. The real science is more careful than that. But carbon-rich worlds are possible in theory, and they remind us that rocky planets do not all need to be built like Earth. A hidden rocky planet might have dark carbon minerals, strange crust chemistry, and an atmosphere shaped by different gases. Its mountains might not be made from the same familiar silicates. Its interior might follow a different recipe. The planet would still be round, still pulled by gravity, still circling its star, but its stones could tell a story written in a different chemical language. Some hidden planets may have surfaces shaped by endless winds. A thick atmosphere can move heat around a planet. It can also carve, smooth, and rearrange the surface over long periods of time. On a dry planet, wind may push dust into dunes. It may polish rocks, fill basins, and carry fine grains across open plains. If the planet is tidally locked, winds might blow from the hot day side toward the cold night side. The atmosphere could become a planet-wide engine. There may be no oceans, no forests, and no rivers. Yet the surface would not be still. It would be shaped by air. Hidden planets with strong winds might have landscapes that slowly migrate. Dunes could move like waves. Dust could gather in long, soft bands. From far away, we might only know the planet's size and orbit. But on the surface, wind could be writing patterns into the ground for millions of years. A quiet planet is not always motionless. Sometimes its movement is simply too slow and distant for us to see. Some hidden planets may have no solid surface at all. Gas giants like Jupiter and Saturn are not worlds where you could stand in the ordinary way. Their outer layers are made mostly of gas, becoming denser and stranger with depth. Around other stars, many hidden planets may be gas giants too. Some are hot and swollen. Some are colder and farther away. A gas giant can be enormous without having a surface like Earth. If you descended into one, the pressure would increase until the idea of air and liquid begins to blur. Clouds could stretch across vast distances. Storms could last for years. Winds could move faster than any storm on Earth. The planet may be hidden not only by distance, but by its own layers. There is no simple ground waiting beneath a blue sky. Instead, there are bands, clouds, storms, pressure, and depth. Such a world is difficult to imagine from a human point of view. We are creatures of surfaces, but many planets may be worlds of atmosphere, not land. Some hidden planets may be unusually light for their size. A planet's size does not always tell us how heavy it is. Some planets are puffed up, with large diameters and low densities. This can happen especially with hot gas giants close to their stars. Intense heat may expand their atmospheres, making them larger than expected. From far away, such a planet can block a lot of starlight during transit. It may look huge in size, but its mass may be surprisingly modest. These inflated worlds are strange and delicate in a cosmic sense. They are not delicate like soap bubbles, but they are spread out, heated, and swollen. Their outer layers may extend far into space. Some of their atmosphere may even escape over time. A hidden planet like this is not compact and heavy. It is wide, warm, and loosely held at the edges. It reminds us that planets are not just solid balls. Some are vast arrangements of gas, heat, and gravity. Some hidden planets may be unusually dense. Other planets go in the opposite direction. They may be small, heavy, and packed with dense material. A dense planet may contain a large iron core. It might be the leftover center of a world that lost much of its outer layers. If a planet orbits close to its star, intense heat and radiation could strip away lighter materials over time. What remains may be heavier and more compact. Such a world might look quiet from space, but its history could be dramatic. It may have started larger, with more atmosphere or a thicker rocky shell. After billions of years, it may have become a bare, dense remnant. A hidden planet like this is a kind of fossil. It carries the memory of what it used to be. We may only detect its shadow and its pull. But from those clues, astronomers can begin to guess its deeper story. And as the story moves softly onward, there is no need to remember every type of planet. You can let them drift by as shapes in the dark. A moonlit world, a windy world, a carbon-rich world, a planet with auroras over silent poles. Each one is another reminder that the galaxy is not empty. It is filled with quiet places, most of them still hidden from view. Some hidden planets are still forming inside disks of dust and gas, around young stars. Planets do not appear all at once as finished worlds. They grow inside wide, rotating disks made from leftover material. These disks can look soft and beautiful from far away, like faint rings around a newborn star. But inside them, tiny grains of dust are slowly meeting, sticking, breaking, and gathering again. Over long stretches of time, small particles become pebbles. pebbles become larger bodies. Larger bodies begin to pull in more material with gravity. A planet may spend its earliest life hidden in the very disk that is creating it. It may clear a gap in the dust as it grows. It may stir the material around it, leaving rings, spirals, or shadows that hint at something forming inside. Astronomers may not always see the young planet directly. Instead, they see the shape of the disk and wonder what hidden world is carving it. There is something gentle about a planet before it is complete. Not yet a finished place, but already gathering itself in the quiet dark. Some hidden planets may migrate from where they were born. A planet does not always stay in the place where it first formed. In young systems, gravity, gas, and nearby planets can slowly change a planet's path. A giant planet might begin far from its star, where icy material is easier to gather. Later, it may move inward, traveling closer to the star over time. This idea helps explain why some giant planets are found extremely close to their stars. They may not have formed there, but arrive there after a long inward journey. Migration can also affect smaller planets. It can shift their orbits, arrange them into patterns, or push them into crowded inner systems. A hidden planet's location may not tell us where its story began. It may be a traveler carrying the memory of a colder birthplace. This makes planetary systems feel less like fixed diagrams and more like histories. Worlds form, move, settle, and sometimes disturb one another. Even after the star begins to shine, the system may keep changing. Some hidden planets may have been thrown into strange orbits by other planets. Gravity is quiet, but it is powerful. When several planets form around the same star, they can pull on one another for millions of years. If their orbits become unstable, one planet may be pushed closer to the star. Another may be sent outward. In extreme cases, a planet may be thrown out of the system entirely. A hidden planet with a tilted or stretched orbit may carry the sign of an old encounter. It may once have moved in a calmer path. Then another world passed near enough to change everything. These gravitational encounters do not need to involve collisions. Sometimes a near miss is enough. Over time, the system may calm down again. The surviving planets continue orbiting, but their paths remember the disturbance. A strange orbit can be like a footprint left by a vanished event. The planet moves quietly now, but its motion may reveal that long ago, something powerful happened in the dark. Some hidden planets may orbit in chains of resonance. A resonance happens when planets orbit in a repeating rhythm. One planet might complete 2 orbits in the time. Another completes 1. Or 3 planets may move in a more complex pattern, returning again and again to the same gravitational timing. This can make a planetary system feel almost musical. The worlds are not making sound, but their motion has a kind of silent beat. Resonances can help keep planets stable. They can also show that planets moved together in the past, perhaps migrating through a young disk. When astronomers find a chain of hidden planets in resonance, they are seeing more than a list of worlds. They are seeing an arrangement, a rhythm preserved across time. Each planet pulls gently on the others. Each orbit is part of a larger pattern. For a sleepy mind, this is a calm thought. Far away, around a star we cannot visit, planets may be circling in quiet mathematical harmony. Some hidden planets may be packed close together in compact systems. Our solar system has large spaces between many of its planets, but some distant systems are much more crowded. Several planets may orbit closer to their star than Mercury orbits the Sun. Their years may be short, and their paths may be arranged with surprising precision. From far away, these systems can be detected when multiple planets pass in front of the same star. Each one creates its own small dip in the light. The result is like a soft code written in brightness. One dip, then another, each belonging to a different world. A compact system can be very stable if the orbits are arranged well. The planets may pass near one another again and again without falling into chaos. Their skies would be unusual. Neighboring planets might appear large and bright, moving noticeably over time. A hidden world in such a system would not feel alone. It would have companions nearby, circling the same small star in a close and quiet family. Some hidden planets may orbit stars that are younger than the Sun. A young star can be active, bright, and restless. It may send out flares, strong winds, and bursts of radiation. Planets around young stars may still be settling into their long-term forms. Their surfaces may be hot from formation, their atmospheres still changing, and their orbits still adjusting. A young hidden planet might have frequent impacts. It might still be cooling, with volcanic regions and a surface that is not fully quieted down. Its atmosphere may be thick, escaping, rebuilding, or being shaped by the star's early energy. Studying young planets helps astronomers understand what mature worlds may have been like long ago. It is a way of looking at planetary childhood. Earth itself was once young, hot, and changing. The calm blue world we know today came after a long and complicated beginning. Around other stars, hidden young planets may be passing through their own early chapters, softly glowing with leftover heat. Some hidden planets may orbit stars much older than the Sun. An old star system has had more time for quiet changes. Its planets may have circled their star billions and billions of times. Surfaces may be ancient. Impacts may have faded. Atmospheres may have escaped, thickened, or transformed. A hidden planet around an old star could be a world of deep history. Its mountains, if it has them, may be worn down by time. Its oceans, if it has them, may have changed chemistry over ages longer than the history of life on Earth. Older stars can also change as they age. A star may grow brighter over time, slowly altering the conditions on planets that once were cooler. A planet that began in a comfortable region may become too warm. Another farther away may receive more light than it once did. Time itself becomes part of the weather. A hidden planet is not only a place in space, it is also a place in time, shaped by the long life of its star. Some hidden planets may survive the death of their stars. When a star like the Sun reaches the later part of its life, it can expand into a red giant. Inner planets may be scorched, swallowed, or transformed. Afterward, the star may leave behind a white dwarf, a dense glowing remnant slowly cooling in space. It seems strange, but planets or planetary fragments can still exist around such remnants. Some may survive in distant orbits. Others may be broken apart, leaving dusty rings or debris. A planet in a white dwarf system would live under a very different kind of light. The star would be small, hot, and faint compared with its earlier self. Such worlds are hidden pieces of cosmic afterlife. They belong to systems that have already passed through great change. They remind us that planets can outlast the familiar form of their stars. A world may continue circling even after its sun has become something quiet and small. Some hidden planets may have been consumed by their stars. Not every planet survives. Some orbit so close that over time, their stars may pull them inward. As a star ages and expands, it may engulf nearby planets. Those worlds disappear into the outer layers of the star, leaving only chemical traces or changes in rotation. This is not a frightening thought here, only a distant one. It happens over enormous timescales, far beyond a human night. A hidden planet may leave behind no surface, no orbit, and no shadow. But it may still become part of the star it once circled. In that way, planets and stars are not always separate stories. Material can move from one form to another. Dust becomes world. World circles star. Star changes. World returns to fire. The universe is always rearranging itself, softly and slowly, across spans of time too large to hold in the mind. Some hidden planets may be found by studying the debris around stars. When planets form, not all material becomes a planet. Some remains as dust, rocks, comets, and smaller bodies. Around certain stars, astronomers can see disks of debris. These disks may have gaps, clumps, or tilted shapes. A hidden planet may be responsible. Its gravity can shepherd dust, clear paths, or create patterns in the material around it. The planet itself may be too faint to see, but the dust remembers its presence. This is another peaceful kind of detection, not seeing the world, but seeing how nearby particles arrange themselves around it, like wind shaping snow around an unseen stone. A hidden planet may be known by the quiet order it creates. The dust moves. The disk changes. And somewhere within that pattern, a planet may be circling, patient and unseen. There is no need to hold on to every orbit, every method, or every name. You can let the systems turn slowly in the background. Young planets forming in dust. Migrating planets moving inward. Resonant planets circling in rhythm. Old planets surviving around fading stars. Each one is a small thought in a much larger night. Some hidden planets may orbit stars that are too faint for us to notice easily. Not every star in the galaxy shines brightly like the sun. Many are small, dim, and quiet, giving off only a gentle fraction of the light we are used to. A planet around such a star may be hidden twice. It is hidden because planets are faint, and it is hidden because its star is faint too. These systems can be difficult to find in the wide star fields of the sky. A small star may look like only a weak point of light among countless others. Yet around that tiny point, there could be a full planetary system. There could be rocky worlds, frozen worlds, and small planets circling close in the dim red glow. A faint star does not mean an empty star. It may simply mean the whole system lives quietly, with less light, less glare, and a much softer kind of day. Some hidden planets may orbit brown dwarfs. A brown dwarf is larger than a planet. but not quite massive enough to shine like a true star. It sits in the space between categories, too small for steady starlight, but too large to feel like an ordinary planet. Planets around brown dwarfs would be strange to imagine. Their central object might glow faintly when young, then cool and darken over time. A world orbiting there would receive very little light. Its sky might be dim, reddish, and quiet, especially as the brown dwarf ages. Finding planets around brown dwarfs is difficult because the systems are faint. But they are interesting because they test the border between stars and planets. A hidden planet in such a place would live around an object that is itself almost hidden, a dim world. Around a dim, almost star turning slowly through a darker kind of system, some hidden planets may orbit pulsars. Indeed, a pulsar is the collapsed remnant of a massive star, spinning rapidly and sending beams of radiation into space. From Earth, those beams can appear as regular pulses, like a lighthouse turning in the dark. It may sound surprising, but some of the first confirmed planets beyond our solar system were found around a pulsar. These planets are not gentle, Earth-like homes. Their environment would be unusual and harsh, shaped by radiation and the aftermath of a star's violent past. But they are important because they show that planets can exist in places we might not expect. A planet around a pulsar would have a very different sky. Instead of a warm sun, there would be a small, dense remnant, spinning with extraordinary precision. The planet might be hidden from ordinary sight, but the timing of the pulsar can reveal it. The planet's gravity makes tiny changes in the arrival of the pulses. A hidden world can be found by listening to the rhythm of a dead star. Some hidden planets may be made from the remains of destroyed worlds. In some extreme systems, planets may not be first-generation planets. They may form from material left after earlier worlds were broken apart. Around a white dwarf, for example, rocky debris can sometimes be found. This debris may come from asteroids, moons, or planets disturbed after the star changed. If enough material gathers again, it raises a strange possibility. New, smaller bodies might form from the remains of old ones. The idea is quiet and circular. A world breaks. Dust remains. Gravity gathers the dust into new shapes. A hidden planet like this would carry a history written before its own beginning. Its material may have belonged to another body long ago. This reminds us that planets are not always simple first chapters. Some may be second stories, made from fragments and memory. Even in systems that seem old and faded, gravity can still arrange matter into quiet new forms. Some hidden planets may have surfaces covered with impact scars. Young planetary systems can be busy places. Rocks, comets, and smaller bodies may collide with planets as orbits settle. Over time, these impacts leave craters. Some are small and shallow. Others are wide enough to reshape entire regions. If a hidden planet has little atmosphere or weather, those scars may last for billions of years. The surface becomes a record of old collisions. From far away, we may not see the craters at all. We may only know the planet as a size, a shadow, or a gentle pull on its star. But if we could look closer, its surface might be marked with circles, basins, and ancient wounds softened by time. A cratered planet is a quiet archive. It remembers the debris that once moved through its system. Every mark is a meeting between worlds, preserved on stone under a distant sky. Some hidden planets may have active volcanoes. Volcanism is one way a planet releases heat from its interior. It can build mountains, renew surfaces, and send gases into the atmosphere. A hidden rocky planet may look still from far away, but its interior could be warm and active. Molten rock may rise slowly through cracks and weak places in the crust. On some worlds, volcanoes might be gentle and broad. On others, they could be explosive, especially if gases are trapped in the melted rock. Volcanoes can also shape atmospheres. They release gases that may build air around a planet, or change the chemistry of an existing atmosphere. This means a planet's surface and sky can be connected by fire from below. A hidden planet with volcanoes is not just a ball of rock. It is a world exchanging material between its deep interior and the space above. Even far from its star, a planet may have warmth coming from inside. Some hidden planets may have plate tectonics, though we do not know how common this is. On Earth, the outer shell is broken into plates that move slowly over time. This motion helps build mountains, open oceans, recycle rock, and regulate parts of the climate. For distant rocky planets, plate tectonics is difficult to confirm. We cannot see their continents moving, and we cannot watch their deep geology unfold. But scientists wonder which planets might have similar processes. Size, heat, water, composition, and age may all matter. A rocky hidden planet could have a surface that changes slowly over millions of years. Continents might drift, mountains might rise, ocean basins might open and close, or it might have a single outer shell, more like a lid, holding the heat inside differently. Both possibilities are interesting. A planet's surface may look still in a single moment, but across deep time it can behave like something slowly breathing. A hidden world may have a geology we cannot yet read. Some hidden planets may be dry desert worlds. Not every rocky planet has oceans. Some may have lost their water long ago, or formed with very little water in the first place. A desert planet could have wide plains of dust and stone. Its skies might be clear, hazy, or thin, depending on its atmosphere. If the planet has enough air, winds can move sand into enormous dune fields. The landscape might shift quietly over ages. A desert world close to its star could be hot and bright. One farther away could be cold, with dry valleys under a pale sun. Without oceans, the climate may behave very differently from Earth's. Heat may move less evenly, and day-to-night temperature changes could be strong. Still, a desert planet is not an empty idea. Deserts can hold subtle patterns, hidden minerals, ancient channels, and signs of past change. A dry world may once have been wet. Its silence may be the last page of an older story. Some hidden planets may be covered in ice from pole to pole. If a planet orbits far from its star, or if its atmosphere reflects too much light, it may become deeply frozen. Ice could spread across oceans, continents, mountains, and plains. The whole planet might shine pale from space. A global ice world would look quiet, but it could still have complexity. Cracks might cross the surface. Glaciers might move slowly. Dark material might gather in lines and patches. If there is heat inside the planet, liquid water may survive beneath the ice. The frozen outside could become a protective shell rather than a final ending. A hidden ice planet may also change if its star grows brighter or if greenhouse gases build in the atmosphere. Under the right conditions, a frozen world might thaw. This makes ice planets feel patient. They can wait for warmth, holding their secrets beneath a bright white surface. A world can be cold and still have a deep interior story. Some hidden planets may have atmospheres that collapse and return. On very cold worlds, certain gases can freeze onto the surface. If the planet has a long or extreme orbit, its atmosphere might change dramatically with the seasons. When the planet moves far from its star, parts of the atmosphere may condense as frost. The air becomes thinner, and the surface grows coated in frozen gases. Later, when the planet moves closer to warmth, those frosts may turn back into gas. The atmosphere grows again, rising softly from the ground. This is a strange kind of planetary breathing, not with lungs, but with temperature, frost, and sunlight. A hidden planet with this cycle would not have one steady sky. Its air would come and go across its long year. From far away, such changes might be difficult to detect. But on the surface, the difference could be immense. A world may sleep under frozen air, then wake again when its star returns. Some hidden planets may orbit stars in crowded stellar neighborhoods. Stars are not spread evenly through the galaxy. Some regions are loose and quiet, while others are dense with many stars close together. A planet in a crowded region may see a sky filled with bright neighbors. Its night might be richer with starlight than ours. Nearby stars could pass close over long periods of time, gently disturbing distant comets or outer planets. In extreme environments, planetary systems may be shaped by the gravity and radiation of other stars nearby. Such planets might be harder for us to study because crowded star fields are complicated. Light blends together, signals overlap, backgrounds become busy. A hidden planet there is part of a larger neighborhood, not just a single star and its worlds. Its sky may be full, layered, and bright with distant suns. Even in the quiet of sleep, we can imagine a planet under a night sky crowded with stars. Every point of light another possible home for hidden worlds. Some hidden planets may drift between spiral arms of the galaxy. Our galaxy has vast spiral structures filled with stars, gas, and dust. But between those arms, there are still stars and planets moving through the wide disk of the Milky Way. A planet does not know the name of the region it travels through. It simply follows the gravity of its star, while the whole system orbits the galactic center. Over millions of years, star systems move through changing neighborhoods. They may pass near gas clouds, clusters, and regions of new star formation. A hidden planet is part of that larger motion. It orbits its star, and its star orbits the galaxy. There are circles within circles, paths within paths. This can be a calming thought. Even a small planet has more than one journey. It has its local year around a star and a much larger galactic year through the Milky Way. You do not need to hold on to all of this. You can let the scale become soft and distant. A faint star with planets. A planet around a brown dwarf. A cratered world. A frozen world. A desert world. A world whose atmosphere comes and goes like a slow breath. They are all hidden in different ways, and all moving gently through the dark. Some hidden planets may sit in the habitable zones of their stars. The habitable zone is the region where temperatures might allow liquid water on a planet's surface, if the atmosphere is suitable. It does not guarantee that a planet is alive. It does not even guarantee that the planet has water. It only means the distance from the star is not obviously too hot or too cold. A hidden planet in this zone might be rocky, icy, cloudy, dry, or covered in oceans. The same simple distance can lead to many different worlds. Atmosphere matters. Pressure matters. Clouds matter. The planet's history matters. A world can orbit in the right place and still be unwelcoming. Another can sit near the edge and still keep warmth beneath thick air. The habitable zone is not a promise. It is a quiet invitation to look more closely. Some hidden planets may once have been habitable, but are not anymore. A planet can change across time. Its star can grow brighter. Its atmosphere can thin, and its oceans can disappear. A world that once had rivers may later become dry. A world that once had a gentle sky may lose its air to space. This makes hidden planets feel like stories, rather than simple objects. We may discover them at one moment, but their past could be very different. A dry, rocky planet close to its star might have once formed farther away. It may have migrated inward, or its star may have changed around it. A frozen world might have once been warmer. A hot world might have once held cooler oceans. From far away, we see only the present clue. But the planet carries a history no telescope can fully read. Some hidden planets may become habitable only for a short part of their lives. Stars do not stay exactly the same forever. Their brightness can change slowly over billions of years. As a star evolves, the region where liquid water is possible may move outward. A planet that was once too cold may become warmer later. For a time, it might enter a gentle range of temperatures. Ice could melt, atmospheres could shift, and chemistry could become more active. But this window might not last forever. Eventually, the star may grow too bright, and the planet may become too warm. This gives some planets a temporary springtime in cosmic history. Not a season lasting months, but a season lasting millions or billions of years. A hidden world may spend most of its life waiting in cold, then briefly awaken under a changing sun. Some hidden planets may have false signs that look like life. When scientists study distant atmospheres, they look for gases that might suggest biology. But chemistry can be tricky. A gas that life produces on Earth may also be produced by non-living processes somewhere else. Volcanoes, sunlight, oceans, rocks, and atmospheres can interact in complicated ways. They can create signals that need careful interpretation. This is why finding life on a hidden planet would not be a simple matter of spotting one gas. Scientists would need context. They would need to understand the star, the planet, the atmosphere, and the possible chemistry. A hidden world may whisper something interesting, but we must listen carefully. The universe can imitate. It can produce almost life signals through ordinary physics and chemistry. Even wonder needs patience. Some hidden planets may show signs of atmospheres through starlight. When a planet passes in front of its star, a little starlight can filter through the planet's atmosphere. Different gases absorb different colors of light. This means the atmosphere can leave a faint fingerprint in the starlight. The signal is delicate. It is like trying to understand the edge of a soap bubble from across an ocean. But with powerful telescopes, astronomers can sometimes begin to identify molecules. They may look for water vapor, methane, carbon dioxide, sodium, or other atmospheric clues. This does not reveal a complete sky. It does not show clouds drifting or winds blowing over mountains, but it gives a first hint of what surrounds the planet. A hidden planet may remain unseen, while its atmosphere writes a thin signature into passing light. Some hidden planets may have no atmosphere at all. A small rocky world close to its star may lose its air over time. Strong radiation, weak gravity, or violent impacts can strip an atmosphere away. Without air, the surface is exposed directly to space. Temperatures may swing sharply between day and night. There would be no clouds, no wind, and no soft blue layer above the ground. The sky would be black even during the day, with the star blazing from one direction. A planet without atmosphere is not empty of interest. Its rocks may preserve ancient impacts, volcanic plains, or traces of earlier conditions. It might once have had air. It might once have had water. It might be the quiet remnant of a more active world. Sometimes, what is missing tells part of the story. Ments. Some hidden planets may have atmospheres too thick for light to reach the ground. A dense atmosphere can scatter, absorb, and trap light. It can hide the surface so completely that even nearby observation would be difficult. From outside, the planet might look smooth and cloudy. Below the cloud tops, the pressure and temperature may increase dramatically. There could be winds moving through deep layers. There could be chemistry happening in clouds far above the ground. The surface, if one exists, may be dark, hot, or crushed beneath heavy air. A world like this is hidden by its own sky. We may know the planet is there. We may know its size and orbit. But the ground remains private. There is something almost dreamlike about a planet that wears its atmosphere like a curtain. Some hidden planets may be shaped by invisible stellar winds. Stars release streams of charged particles into space. Our sun does this too, sending the solar wind through the solar system. Around active stars, this wind can be stronger and more restless. It can push against planetary atmospheres and magnetic fields. A planet close to its star may live inside a constant flow of particles. Its upper atmosphere may be heated, stretched, or slowly eroded. If the planet has a magnetic field, the stellar wind may wrap around it. If not, the atmosphere may be more exposed. This interaction is invisible to human eyes, but it matters deeply. A hidden planet is not only orbiting through empty space, it is moving through the breath of its star. Some hidden planets may have climates controlled by clouds. Clouds can warm a planet by trapping heat. They can also cool a planet by reflecting starlight back into space. The effect depends on their height, thickness, composition, and how much of the planet they cover. On a tidally locked world, clouds might gather on the star-facing side. They could reflect sunlight and help prevent the surface from overheating. On another planet, thick clouds might trap warmth and create a powerful greenhouse effect. Clouds are soft in appearance, but powerful in climate. A hidden planet's future may depend on layers of vapor and droplets moving above its surface. From far away, clouds may look like a problem because they block our view. But for the planet itself, they may be part of its balance. Some hidden planets may have oceans that regulate their temperatures. Water can store and move heat. On Earth, oceans help soften the climate and carry warmth around the globe. A distant ocean planet might also use its seas to balance day and night, summer and winter, or warm and cold regions. If it spins, currents may circle through basins. If it is tidally locked, water may move heat from the bright side toward the dark side. Waves, currents, ice, and clouds could all work together in a slow climate system. We may not see those oceans directly. We may only infer them from density, atmosphere, or future measurements. But the idea remains peaceful. A hidden planet with dark seas under another sun, moving warmth from one place to another, a quiet ocean doing quiet work. Some hidden planets may have seasons unlike anything on Earth. Seasons depend on tilt, orbit, atmosphere, and distance from the star. Change any of these and the rhythm of a planet can become unfamiliar. A planet with a strong tilt may have extreme seasons. One pole could face its star for long periods, then fall into long darkness. A planet in an oval orbit may have seasons driven more by distance than tilt. Its whole world may warm and cool as it travels closer and farther. A tidally locked planet may not have ordinary days, but it might still have climate cycles. Weather could shift as the atmosphere moves and responds. There is no single way for a planet to have a year. Some years are gentle circles. Some are long swings through heat and cold. Some are almost still beneath a fixed star. The more we learn, the less ordinary our own seasons seem. Some hidden planets may have skies where the star never moves. On a tidally locked world, the star may stay in nearly the same place overhead. It would not rise in the east or set in the west. For someone standing on the day side, the star could hang forever in the sky. Shadows might point in the same direction for years. On the night side, the star would never appear. The sky would remain dark, perhaps filled with stars and the glow of distant planets. Near the boundary between day and night, the star might rest close to the horizon. It could look like an endless sunset. This kind of sky is difficult to imagine because Earth's sky is always moving. But elsewhere, a planet may live under a fixed sun. Its days are not counted by sunrise and sunset. They are measured by winds, temperatures, and the slow circulation of air. You can let that image become soft now. A star hanging still. A dark side full of night. A twilight band wrapped gently around the world. Some hidden planets may be more common than stars. Astronomers have found enough planets around other stars to suggest that planets are not rare. They may be one of the galaxy's ordinary creations. Many stars likely have planets. Some may have several. Some may have small rocky worlds that are very hard to detect. And beyond the planets tied to stars, there may also be free-floating worlds moving alone. This means the Milky Way may be filled with planets we will never name individually. Not because they are unimportant, but because there are so many. They turn, drift, freeze, warm, shine faintly, hide in glare, and bend light for a moment before vanishing again. The galaxy is not only a river of stars, it is also a river of worlds. Most of them are quiet. Most of them are hidden. And still, they are there. Some hidden planets may be found around stars we have already studied for years. A star can seem ordinary for a long time. It may be measured, cataloged, and watched without anyone knowing that small worlds are moving around it. Then, after many careful observations, a pattern appears. A tiny dimming. A slight wobble. A rhythm that was too soft to notice before. The planet was not new. It had been there all along. Only our attention became patient enough to find it. This is one of the quiet lessons of astronomy. Discovery does not always mean something has changed in the universe. Sometimes it means we have finally learned how to see what was already there. Some hidden planets may be missed because their stars are noisy. Stars are not perfectly steady lamps. They pulse, flare, rotate, and change in brightness. Dark star spots can move across their surfaces. Bright regions can appear and fade. Magnetic activity can create signals that look confusing from far away. When astronomers search for planets, they have to separate the planet's signal from the star's own behavior. A tiny dip in brightness might be a planet, but it might also be a star spot. A small shift in starlight might be caused by a planet's gravity, but it might also come from activity on the star itself. This makes some hidden planets difficult to confirm. They are not only faint, they are hidden inside the restless light of their stars. A quiet planet may be circling a noisy sun. Some hidden planets may be discovered only after years of repeated measurements. There are worlds that cannot be revealed in a single night. Their signals are too slow, too subtle, or too uncertain. Astronomers may need to return to the same star again and again. They may measure its brightness, its motion, or its spectrum across months and years. Over time, the faint pattern becomes clearer. A long period planet may take many years to complete one orbit. Detecting it means waiting long enough to see the curve of its motion. This kind of discovery feels especially patient. It belongs to people, telescopes, and instruments that keep watch long after the first look. A hidden planet does not always whisper quickly. Sometimes it waits inside the data, becoming visible only when time has gathered enough evidence. Some hidden planets may be hidden in old telescope data. When new methods are developed, scientists can return to observations collected years earlier. A planet that was missed at first may appear when the data is studied in a new way. This means a discovery can be both old and new at the same time. The light may have arrived years ago. The telescope may have recorded it quietly. The planet's signal may have been stored, unnoticed, inside a file. Later, someone asks a better question, a new algorithm, a new comparison, or a new understanding brings the hidden pattern forward. The planet was already present in the light. It was only waiting for the right kind of attention. There is something soothing about that idea. Sometimes the universe has already given us the answer. We simply have not learned how to read it yet. Some hidden planets may be confused with other planets in the same system. When several planets orbit one star, their signals can overlap. One planet may cause a transit, another may tug on the star, and another may slightly change the timing of its neighbors. The system becomes a quiet puzzle. Astronomers have to work out which signal belongs to which world. They look for repeating periods, matching patterns, and gravitational effects. A hidden planet may reveal itself only because it disturbs another planet. If one known planet transits slightly early or slightly late, that timing change can suggest another unseen world nearby. The hidden planet may not cross a star from our view, but its gravity still affects the planet that does. In this way, one world can announce another. A visible rhythm can carry the signature of something invisible. Some hidden planets may have colors we can only estimate. When astronomers try to understand a distant planet, they may measure how it reflects or emits light. But for most exoplanets, color is not easy to see directly. A planet might be blue because of oceans, or haze, or scattering in the atmosphere. It might be red because of dust, heat, or the type of star shining on it. Color from far away is a clue, not a complete answer. A hidden planet may have a surface and sky that would surprise us completely. Our best models might be close, or they might miss the feeling of the place. It is easy to imagine a soft blue world, but the real planet might be copper, gray, gold, violet, or nearly black. The universe does not need to use the colors we expect. Somewhere, a hidden planet may be circling in a shade no human eye has ever seen. Some hidden planets may have clouds made from minerals. On very hot worlds, materials that are solid on Earth can behave differently. Rocks, metals, and minerals can vaporize, move through the atmosphere, and condense again. High above a hot planet, tiny mineral particles may form clouds. These clouds would not be made of water droplets like mini clouds on Earth. They might contain silicates, metal compounds, or other materials shaped by extreme heat. The sky of such a planet could be hazy and strange. Its clouds might glow, darken, or reflect light in unfamiliar ways. If the winds are strong, those mineral clouds may move around the planet at great speed. From far away, we might only detect a flat or muted atmospheric signal. The details would remain hidden, but in imagination the sky becomes vast and alien. Clouds of stone, drifting softly above a world we will never touch. Some hidden planets may reflect almost all the light that reaches them. A bright planet can be hidden too. If it is too close to its star from our point of view, the star's glare may overwhelm it. A world covered in reflective clouds or ice might shine strongly, but still be difficult to separate from its sun. Brightness alone does not make a planet easy to find. The challenge is contrast. A tiny bright object beside a much brighter object can disappear in the glare. This is why direct imaging is so difficult. Telescopes must block or reduce the star's light to reveal the faint planet nearby. It is a delicate kind of seeing. A planet may be bright in itself, glowing with reflected light, while still being hidden by a brighter companion. Pearl beside a flame can still be hard to see. Some hidden planets may be detected by blocking the light of their stars. Directly imaging an exoplanet often requires special tools that reduce the star's glare. A coronagraph can help by covering the star's light, making nearby faint objects easier to see. This is similar in spirit to holding up a hand to block the sun, so you can see something dimmer nearby. Of course, in astronomy, the task is far more precise. The star is distant, the planet is faint, and the light must be carefully controlled. Only certain planets are easier to image directly. Large young planets far from their stars are better targets because they can still glow with heat from formation. Smaller Earth-like planets close to their stars are much harder. Still, the method is powerful because it can sometimes give us actual light from the planet itself. Not only a shadow, not only a wobble, a faint point of planetary light. some hidden planets may still glow from the heat of their formation. When a giant planet is young, it can be warm inside. It may give off infrared light as it slowly cools. This makes young giant planets easier to see than older cold ones. They are still radiating leftover heat from the time they formed. A young planet far from its star may appear as a faint, warm dot in infrared images. It may not shine like a star, but it has a quiet heat of its own. Over time, that heat fades. The planet cools and becomes harder to detect. This means age matters. A planet that is visible when young may become hidden later in life. The universe is full of things that are easiest to see only during a certain chapter of their story. A planet can begin warm, invisible, then slowly drift into darkness. Some hidden planets may have days that last longer than their years. A planet's day is the time it takes to rotate once. Its year is the time it takes to orbit its star. On Earth, the day is much shorter than the year. But other planets can be different. If a planet rotates very slowly and orbits close to its star, one day could last longer than 1 year. This would make sunlight behave in unfamiliar ways. The star might crawl across the sky at an extremely slow pace, or barely move at all. Weather, temperature, and surface conditions could depend strongly on that slow rotation. A long day can change how heat spreads. One side may warm for a very long time, while another cools under extended darkness. Time on such a world would not feel like time here. Morning, noon, evening, and night could stretch into something vast and slow. Some hidden planets may rotate sideways. A planet's axis can be tilted. Earth's tilt gives us seasons, but other planets may have much stronger tilts. A world rotating almost on its side would have unusual patterns of light and darkness. Its poles might receive long periods of sunlight, then long periods of night. The seasons could be extreme and beautiful. One hemisphere might lean toward the star for a long stretch of the year, while the other faces away into cold. Later, the situation would reverse. If the planet has an atmosphere or ocean, they would respond to this slow shifting of heat. A hidden planet like this may have climate patterns that rise and fall in great waves across its year. It would still be a planet following simple gravity, but its experience of sunlight would be completely different from ours. Some hidden planets may have invisible rings of radiation around them. A planet with a strong magnetic field can trap charged particles, creating radiation belts. Earth has these, and giant planets can have much stronger ones. Around another world, such belts might be vast. They could surround the planet like invisible shells. A moon moving through them might experience intense particle storms. The planet's atmosphere might glow where particles follow magnetic lines toward the poles. These structures are difficult to see from far away, but they shape the space around the planet. A hidden planet is not only its surface or clouds. It also has an environment around it, made from magnetism, particles, and motion. The planet reaches outward without touching anything. It holds a silent shape in space. Some hidden planets may have moons that create tides in their oceans. If a planet has large moons, their gravity can pull on any oceans the planet may have. This creates tides, rising and falling across the surface. On Earth, the moon helps shape the rhythm of the seas. Around another planet, tides could be weaker, stronger, slower, or more complex. If there are several moons, the pattern may become layered. Oceans might respond to more than one gravitational pull. Tides can also affect coastlines, ice shelves, and even the interior of a world. A hidden ocean planet with moons may be full of slow movement. Water rises, falls, circulates, and changes under alien skies. From far away, no telescope may see the tide, but the rhythm could be there. A quiet ocean, answering a moon we have not yet found. Some hidden planets may have no moons at all. Not every planet needs a moon. Some may travel alone around their stars, with no companion world nearby. Without a large moon, a planet's tilts might behave differently over long timescales. Its tides may be weaker, and its nights may be darker, but a moonless planet is not incomplete. It is simply a different kind of world. Its sky might be clear of any large nearby body. Only stars, clouds, and perhaps other planets would move overhead. The absence of a moon could make the night feel wide and open. A hidden planet without moons may still have mountains, winds, oceans, ice, or storms. It may still have a long and rich story. Sometimes what a world lacks is part of its quiet character, and now the hidden planets can pass through the mind slowly. A planet glowing with leftover heat. A planet with mineral clouds. A planet with sideways seasons. A planet with tides beneath strange moons. There is no need to count them. They can simply drift, one after another, like dim lights moving through the deep sky. Some hidden planets may have skies filled with dust. Dust in an atmosphere can soften the light of a star. It can turn a sharp blue sky into something hazy, golden, red, or brown. On a dry, rocky planet, fine particles may be lifted by wind and carried across wide plains. The air may never become completely clear. If the planet has strong seasonal changes, dust storms might grow during warmer parts of the year. They may spread across regions, continents, or even the whole planet. From space, a dusty world could look muted and mysterious. Its surface details might blur beneath moving veils of fine material. Dust can also affect climate. It can reflect starlight, absorb warmth, and change how temperatures move between day and night. A hidden planet with dust in its sky may not look bright and clean. It may look softly covered, as if the whole world is wrapped in a thin, restless blanket. Some hidden planets may have surfaces shaped by ancient rivers. A planet does not need rivers today to show signs of water in the past. Dry channels, carved valleys, and mineral deposits can remain long after the water is gone. On Earth and Mars, landscapes can preserve traces of old flowing water. Around another star, a hidden rocky planet might also carry dry riverbeds from an earlier age. Its present surface may be cold, dry, or thin-aired, but long ago, rain may have fallen, streams may have gathered, and lakes may have reflected a different sky. These signs would be almost impossible to see across interstellar distances with today's telescopes. We may know the planet exists, but not the details of its old valleys. Still, it is peaceful to imagine. A quiet desert world may once have heard the sound of water moving over stone. Some hidden planets may be locked in repeating gravitational patterns with their moons. A moon and planet do not simply move separately. They pull on one another, trade energy, and slowly shape each other's motion. Over long periods of time, a moon can slow a planet's rotation. A planet can push a moon outward. Their orbits can settle into repeating rhythms. If a hidden planet has several moons, the system may become even more delicate. one moon may tug on another, keeping their orbits in a quiet pattern. These patterns can create tidal heating. They can shape oceans, cracks, volcanoes, and ice shells. A hidden planet may seem like one object from far away, but up close, it could be a small gravitational family. Planet and moons circling together, making slow changes that only time can hear. Some hidden planets may have storms larger than Earth. On giant planets, storms can grow to enormous sizes. In our own solar system, Jupiter's Great Red Spot is a familiar example of a storm far larger than ordinary weather on Earth. Around other stars, giant planets may have storms we have never seen. Some may be shaped by intense heat from their stars. Others may be driven by deep internal warmth. A hot giant planet may have fierce winds carrying heat from the day side to the night side. Clouds may form, vanish, and return in long atmospheric cycles. From far away, we may notice only changes in brightness or temperature. Those changes may hint that weather is moving across the planet. A hidden planet's atmosphere can be active, even when the planet itself is only a faint signal in data. Somewhere, a storm larger than our world may be turning silently around a distant planet. Some hidden planets may have nights brighter than expected. A planet's night side may not always be completely dark. Heat from the day side can be carried around by winds, oceans, or the movement of the atmosphere. On a hot giant planet, the night side may glow in infrared light. It may still be warm enough to radiate heat even though it faces away from the star. If a planet has thick clouds, auroras, lightning, or volcanic activity, its darkness may contain many kinds of faint light. A nearby moon or ring system could also reflect starlight into the night. This means night on another world may not feel like night on Earth. It could be dim red, softly glowing, or lit by a giant companion in the sky. A hidden planet may have a night side that is quiet, but not completely black. Some hidden planets may have lightning in their clouds. Lightning is a release of electrical energy, and it can happen when particles inside clouds separate charge. On Earth, it is common in thunderstorms. On other planets, lightning may occur in very different atmospheres. Giant planets, dusty worlds, or planets with thick cloud decks may all have the ingredients for electrical storms. The flashes might be hidden beneath clouds. They might flicker deep in the atmosphere, never reaching a clear sky. For a distant observer, lightning would be extremely hard to detect. But it may still be part of the weather on many worlds. A hidden planet with lightning would have brief moments of brightness inside its own clouds. For an instant, a storm reveals itself. Then the light disappears, and the world becomes quiet again. Some hidden planets may have air that smells nothing like Earth. We cannot truly smell another planet from far away. But chemistry gives us hints about what its atmosphere might contain. Some atmospheres may be rich in hydrogen. Others may contain carbon dioxide, methane, sulfur compounds, or gases produced by volcanic activity. The surface and sky might have a chemical character completely unfamiliar to us. Earth's air feels invisible and neutral because we are made for it. On another planet, the air could be sharp, metallic, sulfurous. sweet, or impossible for a human body to breathe. This does not make the planet less interesting. It makes it more clearly itself. A hidden world has its own atmosphere, its own balance, and its own chemistry. Even without visiting, we can imagine that every planet has a kind of invisible personality written in its air. Some hidden planets may have gravity much stronger than Earth's. A planet larger and denser than Earth could pull much harder on everything at its surface. Mountains might not rise as high. Atmospheres might cling more tightly. Walking there, if it were possible, would feel heavy and slow. Every movement would require more effort. The planet's landscape might be shaped by that gravity. Tall cliffs could collapse more easily. Broad, low features might be more common than sharp, towering peaks. A stronger gravity could also help the planet hold on to a thicker atmosphere. The sky might press down more heavily, and gases might remain for longer periods of time. A hidden planet's gravity is not just a number. It shapes the feeling of the world. It decides how high dust can rise, how air is held, how waves move, and how mountains endure. Some hidden planets may have gravity much weaker than Earth's. A smaller planet may not hold on to its atmosphere as easily. Over time, gas can escape into space, especially if the planet is close to an active star. With weaker gravity, mountains might go taller before collapsing. Dust could rise more easily. Impacts might throw material farther across the surface. If a world is too small, it may cool quickly inside. Its volcanoes may fade. Its magnetic field may weaken, and its atmosphere may become thin. But a small planet can still be beautiful and complex. It may have craters, frozen regions, old lava plains, or traces of vanished air. A hidden world does not need to be Earth-sized to matter. It can be small, quiet, and ancient, circling its star with a thin sky or no sky at all. Some hidden planets may be shaped by collisions with other young worlds. During the early life of a planetary system, many growing bodies may share overlapping paths. Collisions can happen, and they can change everything. A large impact might tilt a planet, strip away part of its crust, create a moon, or melt much of the surface. The aftermath may take thousands or millions of years to cool. A young planet may glow with heat after such a collision. From far away, we might never know the details. But a planet's strange spin, unusual density, or missing atmosphere could hint at an old impact. Many worlds may carry the memory of collisions that happened before they were fully formed. A hidden planet may look calm today because enough time has passed. But long ago, it may have been part of a bright and violent beginning. Some hidden planets may be surrounded by clouds of escaping gas. When a planet loses atmosphere, the gas does not always vanish instantly. It may spread around the planet or trail behind it along the orbit. This cloud can make the planet appear larger in certain kinds of light. It may reveal hydrogen, helium, or other escaping material. A planet like this is not only a solid or gaseous world. It is also a process happening in time. Its upper atmosphere is being lifted away, atom by atom, by heat and radiation. The image is quiet when imagined from far away. A world moving around its star, surrounded by a faint envelope that slowly thins into space. Loss is part of planetary history. Some planets keep their air for billions of years. Others slowly let it go. Some hidden planets may have surfaces made young again by constant activity. A planet's surface age depends on how often it is renewed. Lava flows, tectonics, erosion, impacts, and weather can all erase older features. A world with active geology may have fewer craters because new material keeps covering the old surface. Another world, geologically quiet, may keep ancient marks for billions of years. For hidden planets, we usually cannot see this directly. But understanding surface renewal helps scientists imagine what kinds of landscapes may exist. A young-looking planet is not always young. It may simply be active. Its rocks may be recycled. Its volcanoes may still flow. Its atmosphere may still move material from one place to another. A hidden planet can keep changing its face, even when no one is watching. Some hidden planets may have ancient surfaces that barely change. Other worlds may be almost frozen in time, with little atmosphere, no flowing water, and little internal heat. Their surfaces may preserve very old features. Craters may remain sharp. Lava plains may stay visible. Dust may settle and remain undisturbed for long ages. A planet like this becomes a memory keeper. It does not erase its past quickly. It holds onto the marks of impacts, cracks, and ancient cooling. From a distance, we may know almost nothing about the surface. But if we could see it, it might be like reading a very old book written in stone. Some hidden planets are not dramatic because they are changing quickly. They are strange because they have hardly changed at all. And now, the hidden worlds keep moving softly through the mind. Dusty skies, ancient rivers, giant storms, lightning inside clouds, heavy worlds, light worlds, young surfaces, old surfaces. You can let them pass without trying to remember them. The story is only here to keep you company while the night grows quieter. Some hidden planets may be almost completely covered by clouds of haze. Haze is different from ordinary clouds. It can be made from tiny particles created when starlight changes chemicals high in the atmosphere. On some worlds, ultraviolet light may break apart molecules, allowing new compounds to form. These compounds can gather into fine, misty layers. A hazy atmosphere can hide what lies below. It can soften the star's light and make the planet look smooth, muted, or strangely colored. From far away, haze can make it harder to study the atmosphere. The details become blurred, like trying to see a landscape through frosted glass. But haze is not just an obstacle, it is also part of the planet's story. It tells us that chemistry is happening in the sky. Light and air are meeting, changing, and making something new. A hidden planet wrapped in haze may be quiet to the eye, but chemically active above its unseen surface. Some hidden planets may have atmospheres rich in hydrogen. Hydrogen is the lightest element, and it is common throughout the universe. Many large planets hold thick layers of it. A hydrogen-rich atmosphere can make a planet appear larger during a transit. The gas spreads outward, creating an extended envelope around the world. For smaller planets, keeping hydrogen is harder. Their gravity may not be strong enough, especially if they orbit close to an active star. But some planets between Earth and Neptune in size may hold on to thick hydrogen layers. These worlds can be very different from rocky planets like Earth. They may have high pressure, deep atmospheres, and no comfortable surface to stand on. A hidden planet like this may look simple as a shadow, but inside, it could be a deep and layered world of gas, heat, and pressure. Some hidden planets may have atmospheres rich in carbon dioxide. Carbon dioxide can trap heat, making it important for climate. On Earth, it is a small part of the atmosphere, but it has a powerful effect. On another planet, carbon dioxide might be much more abundant. It could help keep a cold world warmer than it would otherwise be, but too much can create a heavy greenhouse effect. A planet may become hot, dense, and difficult for surface water to remain stable. Carbon dioxide can also freeze under cold conditions. On a very cold world, it might fall as frost or form polar caps. This one molecule can tell many different stories. It can warm a planet. It can weigh down a sky. It can freeze onto the ground. It can shape the boundary between comfort and extremes. A hidden planet's climate may depend on a gas we cannot see with ordinary eyes. Some hidden planets may have methane in their skies. Methane is a simple molecule, but in a planetary atmosphere it can be important. It can absorb heat and take part in complex chemistry. On some worlds, methane may help form haze. On others, it may exist in cold air, clouds, or even rain. In our own solar system, Titan shows us that methane can behave in ways that feel almost like water does on Earth. It can move through the atmosphere and shape the surface. Around distant stars, methane may appear in different kinds of planets. It may be part of giant planet atmospheres, cool worlds, or strange hazy skies. Scientists are careful with methane because it can come from living or non-living sources. A hidden planet with methane is not automatically alive. It is simply chemically interesting. It is another quiet clue. Another small piece of a much larger atmospheric puzzle. Some hidden planets may have oxygen without life. On Earth, oxygen is strongly connected to plants, algae, and photosynthesis. But on other planets, oxygen can sometimes build up without biology. Starlight can split water vapor in the atmosphere. Hydrogen may escape into space more easily, leaving oxygen behind. Other chemical processes may also create oxygen or oxygen-related signals without living organisms. This is why scientists are cautious when they search for life. A single gas is rarely enough to prove anything. A hidden planet could show oxygen and still be lifeless. Or it could show no obvious oxygen and still have interesting chemistry below the surface. The universe does not label its worlds clearly. It gives clues, and we must learn to read them with care. That carefulness makes the search more beautiful, not less. It means every hidden planet deserves patience. Some hidden planets may have no clear boundary between ocean and atmosphere. On certain worlds, especially those with high pressure and high temperatures, water may behave in unusual ways. It may become a supercritical fluid, neither ordinary liquid nor ordinary gas. The familiar line between sea and sky may disappear. A planet like this would not have oceans like Earth. It might have deep layers where pressure and temperature change water into unfamiliar states. From far away, the planet might appear to have water in its atmosphere. But that does not tell us whether there are calm seas below. Water is simple in daily life, but strange under extreme conditions. It can freeze into unusual ices. It can become vapor. It can flow. It can change into states that do not fit ordinary experience. A hidden water-rich planet may not be a blue ocean world. It may be something much harder to imagine. Some hidden planets may be rich in iron, iron is important in rocky planets. It can sink toward the center during formation, helping create a dense metallic core. A planet with a large iron core may be heavier than another planet of the same size. Its density can give astronomers clues about its interior. Some planets may be especially iron-rich because of how they formed. Others may have lost lighter outer layers in giant impacts. An iron-rich world could have a strong core, unusual geology, and perhaps a magnetic field if the interior remains active. Its surface might be rocky and dark. Its mountains and plains could be shaped by a dense interior that we cannot see from far away. It may be only a small shadow crossing a star, but deep inside, the planet may hold a heavy heart of metal. Some hidden planets may be poor in iron and rich in lighter rock. Not all rocky worlds are built from the same recipe. Some may have smaller cores and thicker outer layers of silicate rock. A planet's composition depends on the material available in the disk where it formed. Different regions around a star can produce different mixtures. Two planets of similar size may have different interiors. One may be dense and metal-rich, while another is lighter and rockier. This affects gravity, geology, magnetic fields, and long-term evolution. A hidden planet's surface may not reveal its whole interior. Even if we could see mountains and plains, the deeper structure would remain partly secret. Astronomers often work from size and mass, trying to understand what kind of world could match the measurements. A planet's shadow tells us its width. Its gravity tells us its weight. The rest is a quiet mystery inside. Some hidden planets may be covered in salt flats. If a planet once had shallow seas or lakes that later dried away, minerals could remain behind. Salt and other deposits might spread across wide basins. On Earth, salt flats can appear pale, smooth, and almost unreal. Around another star, similar landscapes could exist under very different skies. A dry, hidden planet may preserve the memory of vanished water and bright mineral plains. The air above them might be thin. The climate might be harsh. But the ground could still remember an earlier wet chapter. These surfaces would be hard to detect from far away. We may only guess from the planet's size, atmosphere, and possible history, but the image is calm and simple. A silent basin. A pale crust of minerals. A low sun moving through a dusty sky. Sometimes a hidden planet's most interesting feature is the trace of something no longer there. Some hidden planets may have permanent glaciers. A planet does not have to be entirely frozen to hold long-lasting ice. In cold regions, glaciers may form and slowly move across the surface. If the planet has mountains, ice can gather at high elevations. If it has tilted seasons, glaciers may advance and retreat over long cycles. On a world with a thick atmosphere, snow may fall gently for thousands of years. Layers of ice may build, compress, and begin to flow. Glaciers are slow, but they are powerful. They carve valleys, grind rock, and carry material across landscapes. A hidden planet with glaciers would have motion that is almost too slow to notice. The ice would move like time made visible. From far away, the world may seem still. But on the ground, frozen rivers may be shaping it in silence. Some hidden planets may have underground caves. Caves can form in many ways. Flowing water can dissolve rock. Lava tubes can remain after molten rock drains away. On another rocky planet, caves might exist beneath volcanic plains, ice layers, or mineral crusts. They could be protected from radiation, temperature swings, and impacts. If a planet has harsh surface conditions, the underground may be more stable. This is why caves are interesting in the search for life. They can shelter chemistry, ice, or trapped air. A hidden planet may look bare and dry from above. But below the surface, there may be hollow spaces, dark passages, and quiet chambers. No telescope can see them from Earth. They would be hidden inside a hidden world. The idea is soft and deep. A planet with secrets not only across its surface, but beneath it. Some hidden planets may have internal oceans without surface water. A planet can be dry on the outside and still hold water below. Water can be trapped in minerals, stored in deep layers, or sealed beneath ice. If enough heat exists inside, subsurface reservoirs may remain liquid. They may be isolated from the surface for long periods of time. This kind of hidden water would be extremely difficult to detect from far away. It might not create blue oceans, clouds, or obvious atmospheric signs, but it could still matter greatly for geology and chemistry. A planet's surface may tell only the simplest part of the story. The deeper layers may hold the quiet things. Hidden water, hidden heat, hidden movement. A world can appear silent while something slow and important continues below. Some hidden planets may be more like moons than planets in our imagination. When we think of planets, we often imagine large independent worlds. But some exoplanets may be small, rocky, and airless, more like Mercury or the Moon. They may have cratered surfaces, thin or absent atmospheres, and long records of impacts. Their skies may be black. Their days may be hot, their nights cold, and their surfaces covered in dust and stone. These worlds may not be comfortable, but they are still part of the galactic population. They are still planets, shaped by gravity and time. A small hidden planet may not have oceans or clouds. It may not have storms or seasons in a familiar way, yet it has a history. It formed, cooled, was struck by debris, and continued circling its star. Even the quietest stone world belongs to the larger story, and as these hidden places pass through the mind, you can let the details become lighter, a hazy world, a methane sky, a salt flat, a glacier, a cave below a silent plain. The universe does not hurry to reveal them. And tonight, there is no need for us to hurry either. Some hidden planets may never be found by us. They may be too small, too far away, too cold, or too quiet. They may orbit stars too faint to study, or drift alone through spaces where no telescope happens to look. This does not make them less real. A world does not need a name to have mountains. It does not need a catalog number to have clouds, ice, storms, or silence. It can turn slowly in the dark for billions of years, unseen by any eyes at all. Some hidden planets may be waiting for future telescopes. The instruments we have today are far more powerful than those of the past. But they are still only the beginning of what may come. Future telescopes may see smaller planets, colder planets, older planets, and planets more like Earth. They may read atmospheres with greater care and separate faint worlds from the glare of their stars. A planet that is hidden now may not stay hidden forever. One day, a tiny point of light may become a world with weather. A faint shadow may become a place with oceans. A strange signal may become a planet with a story. Discovery is a slow opening of darkness. Some hidden planets may already be known only as hints a slight wobble, a dimming of starlight, a short brightening caused by gravity, a gap in a dusty disk, a rhythm in the timing of another world. These are small clues, but small clues can matter. Astronomy often begins with almost nothing, a fraction of a percent, a tiny shift, a signal buried in noise. Then, patiently, the picture becomes clearer. A hidden planet is not usually found all at once. It arrives like a shape appearing in mist. First, there is uncertainty. Then there is pattern. Then there is a name, and somewhere behind the numbers, there is a world. Some hidden planets may remind us how limited our view really is. From Earth, we see the universe from one small place at one small time, with instruments that are always improving but never complete. There may be planetary systems turned at the wrong angle. There may be planets between stars, moving without light. There may be worlds too distant for their signals to reach us clearly. The sky is not empty just because it looks dark. It is full of quiet things beyond the edge of easy seeing. That can be a comforting thought. Not everything has to be visible to be present. Some of the universe is allowed to remain soft, distant, and unknown. Some hidden planets may be ordinary in their own systems. To us, a distant world can feel strange simply because it is hard to find. But to its own star, it may be just one planet among several. It may follow a stable orbit. It may have seasons, weather, moons, or rings. It may have existed quietly long before humans ever wondered about other worlds. A hidden planet is only hidden from us. In its own place, it belongs completely. It is part of a system, part of a rhythm, part of the long and patient movement of matter around light. There is peace in that idea. Every world has its own center. Every orbit has its own quiet logic. Some hidden planets may be more beautiful than we can imagine, not because they are perfect or gentle or familiar, but because they are themselves. A black planet absorbing almost all the light of its star. A frozen world with an ocean sealed beneath ice. A desert planet under a red sun. A giant world with rings too faint for us to see. A moonlit planet with tides moving in dark seas. A young planet glowing with leftover heat. A small rocky world covered in ancient craters. A planet with a fixed sunset. A planet with two suns. A planet without any sun at all. Each one is a different answer to the same quiet question. What can a world be? And the universe answers in more ways than we can count. As this journey comes toward its end, there's no need to gather all the facts together. You do not need to remember the names of the methods, the kinds of orbits, or the many possible skies. You can let them loosen now. Let the hidden planets become soft shapes in the background of your thoughts. A shadow crossing a star, a faint wobble in distant light, cold world turning beneath ice. A dark planet wandering between suns, blue ocean under clouds no one has ever seen. The galaxy keeps moving, whether we are awake or asleep. Stars continue to shine, dust continues to gather. Planets continue to circle, drift, cool, warm, and wait. Some worlds are being born inside disks of gas and dust. Some are aging around quiet stars. Some have already lost their atmospheres. Some are still wrapped in clouds. Some may be close enough for future telescopes to study. Others may remain hidden, for as long as the galaxy endures. And that is all right. Not every mystery needs to be solved tonight. You can rest inside the wonder of it. You can let the unanswered things stay unanswered. Far beyond the window, beyond the city lights, beyond the familiar moon and the planets we can see, there are countless other worlds moving through the dark. They do not hurry. They do not call attention to themselves. They simply continue, quietly circling, quietly drifting, quietly existing. And now, as the night grows deeper, you can let your own thoughts become just as quiet. Let the hidden planets fade into the distance. Let the stars become soft. Let the dark become calm. There is nothing more you need to follow. The story can keep moving gently in the background while you rest. Somewhere, a planet passes in front of its star. Somewhere, a cold ocean shifts beneath ice. Somewhere, a world without a sunrise drifts through the galaxy. And here, for now, you can simply sleep.